has been really new today on the graphing of things, except maybe reminding yourself that when I ask for roots, that's just in the black. On the previous video, we did everything blue, just like you've done this week, where you set up those boxes, figured out your signs, made sure that each part here was flat, flat, flat at those points, and you were able to draw the sketch. Now, up front, I kind of told you I don't want you to draw the sketch yet until you do the inflection points and you do everything in the second derivative. But for this one, let's just say it's already up there so you can see the visual of it up front. So let's try it now with the inflection points. That means it's the second derivative. Now, this is on a new page, but you already have some info here. You already had f of x was this. You already took one derivative, which is negative 15x to the fourth plus 15x squared. And we're going to take a second derivative now right from here, not after we factor, but just right from here. These are all toy trains. This gets me negative 60x to the third plus 30x. And when I say inflection points, that means that guy has to equal 0. So let's see what we can factor out. We can take a negative 30x out, and I'm going to get 2x squared minus 1 left over. So right away from the first guy, you got x equals 0. And then from the second guy, 2x squared minus 1 equals 0, x squared equals 1/2, x equals the square root of 1/2, or if you remember some pre-calc, that would be the square root of 2 over 2. This problem here, I'll tell you up front, I know you don't like the square root of 5/3, and I know you don't like the square root of 2 over 2. For the most part, the other problems are a little bit nicer. That's why I did this one with you guys. When I find these, this guy and this guy, and remember this is plus or minus on these are my inflection points. So let's take a look at it. If I did set this up with some boxes, I can set this guy up now in a 3-tiered box, just like we've done before with the 1-tiered boxes for my first derivative. But this time it's going to be a second derivative. I have my x's, I have my y's, but instead of y primes, I'm going to have my y double primes. And I'm going to set this up with some blanks. Let's see, I'll go slowly on this. This is x equals negative square root of 2 over 2, blank, x equals 0, blank, and I'm going to need to add on a little bit more here. X equals positive square root of 2 over 2. And as usual, you don't need anything here, 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 here. Save you trouble on this one. This guy is y equals 0. These guys are ugly. So for right now, for this one, let's not worry about finding the y value. You could find it. You could easily find it by plugging in those right into that equation. But for right now, I know you guys already don't like the square roots, so we won't worry about that. My second derivative was 0 here, 0 here, 0 here. We're going to do a sign check. Our sign check can come from either that place or this place. It doesn't matter. All we need to do is plug in values that are in between our intervals and check which ones are positive and which ones are negative. When you do that, square root of 2 over 2, that for you guys, if you're not quite sure, square root of 2 over 2 is 0.707. So this is a 0.707. This is a negative 0.707. So we could check negative 1, negative a half, half, and 1. When you guys do that, so if I plug in a negative number, really negative, like negative 10, negative 10 cubed is negative, times a negative 60 is a big positive number, minus 30 times negative 10. That guy, you can do it on your calculator, or you can trust me, this one's positive. The next one will become negative. The next one will become negative, then positive, then negative. And again, you would go slower than me. I'm just providing you the answer. What I want you to show me with this is on the graph. So, I have at negative square root of 2 over 2, I have an inflection point, which we said was around negative 0.707. Well, if this is negative 1, it's right around here. This is an inflection point. And right around here is an inflection point for the positive 0.707. And right in the middle, the easiest one, is an inflection point there. Now notice how I'm kind of quickly sketching it because of the ugly values on it. The next problem that you're going to do, everything turns out nice. So when I have that, this is all concave up, concave up. So let's show that. I'm going to show this by just scribbling lightly over my graph. That whole region is concave up. And there is actually one more region between 0 and the square root of 2 over 2, which is this part, which is concave up. Now the other parts are, I'll do it in a black. This guy here is concave down, and this guy here is concave down. So notice here, that was bending down, and this was bending down the whole way. Now notice I kind of stretched it out. I shouldn't have stretched it out. It just keeps bending down the whole way. So this is concave down, and that little piece was concave down. Now, as kind of a rehashing of this, everything you did on the first derivative, nothing's new. That's what we've been practicing all week, is on the first derivative. Setting up your box, finding your signs for up, down, and we always graphed it from there. The new add-on to it is checking where that concavity starts to bend from a up to a down to an up to a down. Now the next problem I'm going to give you is actually number 1 on this one. Number 1 on this one, your values are nice. And when I say nice, this part and this part and this part and this part, things turn out nice so you can actually get your values. So what I want you to do is I want you to try number 1. I'll let you hit pause on the recorder right now, try it out, and when you think you have it ready, give enough time to everyone, hit the next slide, and you will see, or hit resume again, and you will see the next slide will hold the answer. And you can check with your partners, check with the board, try this one out. Hopefully you did okay on this one, and like I said, the answers were really nice for the first derivative and for the second derivative. And sorry about that being negative 2/3, that's pretty darn close to being pretty nice. Now notice here, I know you might be getting mad at me because this is the best I can do for a video. On that, if you notice, I didn't actually give you the third piece to that. I've been telling you, you do this, here's your x, here's your y, and here's your y double prime. You can do that. You can definitely add that piece in. And when I have x equals 0, I can plug in 0 and I get y equals 0. That's an inflection point. And I can also, coming back over to here, I can plug in x is negative 2/3 and I can definitely get a y value. Let's just keep it simple, I guess, to avoid some things. And let's just always, for my inflection points, for now, just find the x, not the y. So anytime you do your boxes for your second derivative, I'm okay for today and tomorrow. Find your guys. These are all my x's, and this is just my second derivative. So don't worry about the y values when you do them. Now in the answer key, you're going to get some y values as long as they're nice. But I guess I'm kind of trying to say the last couple that we had plus or minus square root of 2 over 2. And on this last one that you just did, I think it was negative 2/3. Those don't necessarily give you good y values. So either find them or expect them to be ugly. On the next slide, we're going to try another one, and we'll see how well that one goes for you.